Hello guys, thank you for watching this lecture. My name is Jalil Piran and I am an associate professor in the field of artificial intelligence. Welcome to this presentation on Introduction to Database Management Systems. Today, we will explore what databases are, how they work, their history, and their importance in modern applications. So these are the topics that we will cover in this lecture. Let's start with the basics. Data. What is data? Data refers to raw facts and figures, like numbers, text, or images. By themselves, they do not carry meaning. Data is the foundation that, when processed, become useful information. So the ultimate goal is to extract knowledge, wisdom, insight from data. Data is considered as intangible gold with a set of technologies that we call them as information technology or ID. We use them to collect, store, retrieve, transmit, and present data. So data, I can say anything that can be saved on a computer is data. Any collection of information, facts, or statistics that we can analyze them, interpret them, and use them to make decisions. They can have different forms like numbers, text, images, audio, or video. It can be generated from various sources like sensors, surveys, social media, databases, or we can generate data from data. Data can be structured or can be unstructured. When we say structured data, it means they are organized in a specific format like a spreadsheet, database, or CSV files. In here, structured data is typically easier to analyze and manipulate because it follows a consistent format. Alternatively, we can have unstructured data. It means it is not organized in any specific format. Unstructured data can include things like text documents, social media posts, images, or videos. They are typically more difficult to analyze and make sense of them. In general, data is used to provide insights and inform decision-making process. By analyzing data, business, governments, or even individuals can gain a better understanding of trends, patterns, and relationships, which can be used to make more informed decisions. So think of data as the building block of everything we will discuss in this presentation. Then, what is database? Database is simply a collection of interrelated data. It means they are related to each other. And we organize them in a way that makes it easy to store, retrieve, and manage. Imagine database as a digital filing cabinet where everything is neatly arranged and connected and it is ready to be used whenever needed. What is database management system? Database Management System, or DBMS in short, is a software that is used to manage databases. DBMS provides tools for creating, modifying, and querying, asking from data, make queries from data, data retrieval, and also controlling access to database. It means who can access what. This DBMS ensures that the data is stored in a consistent and secure manner, and that can be easily accessed and updated by authorized users only. Databases are used in a wide range of applications, including business, education, healthcare, and government. Databases can be used to store information about customers, products, orders, employees, and many other types of data. By organizing data in databases, organization can improve efficiency, they can reduce errors, and also they can provide better service to their customers. So, in summary, a database management system is the software that powers databases. DBMS acts like a bridge bridge between the data and users. And it offers a convenient and efficient way to store, retrieve, and manage information. It includes both the data itself and a set of programs to interact with data. Now, let's take a quick journey through the history of DBMS. In the 1950s and early 1960s, data processing relied on magnetic tapes. These magnetic tapes were used for storage, and these tapes only allowed sequential access. It means we had to go through everything in order to find what we want. And input was done using something called as punch cards. They were very slow and cumbersome. These punch cards are a type of data storage medium, and that time they were extensively used for storing data. At that time, they were widely used for input data in the early days of computing, particularly in industries such as banking, insurance, and government. By the late 1960s and 1970s, things started to evolve. At that time, hard disks were introduced, and they allowed people to have direct access, no more sequential access. A hard disk, which is also known as hard drive, it's a kind of data storage device that uses magnetic storage to store and retrieve digital information. Hard disks consist of one or more circular disks, as you can see here, or we can call them as platters, and they are coated with a magnetic material and mounted on a spindle that rotates at high speed. Data is read and write through some head, as you can see in this picture, and these head move across the surface of the platters. Then the platters are divided into tracks and sectors, and data is stored in these sectors in a series of magnetic fields, and they can be detected by these heads. Then we had network and hierarchical data models. At that time, they become popular. Then TED Code revolutionized the field by defining relational data model. And he also earned the Turing Award in 1981. Edgar Tedcourt was a British computer scientist and who is widely credited as the father of relational database. He was born in 1923 in England and died in 2003 in the United States. He was a programmer and mathematician at IBM for many years. Around this time, IBM began working on our system prototype, which gave us the first implementation of SQL. In 1980s, research turned into real-world tools. Relational prototypes evolved in commercial systems, and SQL became the industry standard for querying databases. What is SQL? SQL or SQL, you can pronounce, is a structured query language, and it's a programming language we use to manage and manipulate relational databases. It's supported by all major relational database management systems such as Oracle, Microsoft SQL Server, MySQL, and many others. We also saw the rise of parallel and distributed database systems as well as object-oriented database management systems. This allows data to be represented as object, much like the programming like Java and Python. Parallel and distributed database systems are designed to provide increased processing power as well as improved scalability for large and complex database applications. On the other side, object-oriented database management systems is a kind of database management system that is designed to store and manage complex data types using an object-oriented programming paradigm. This type of system is ideal for applications that involve complex data structures or they require high performance and scalability. The 1990s brought big changes. Database started supporting decision making and data mining applications. We saw the rise of massive multi-terabyte data warehouses to store huge amount of information. What is data warehouse? It's a large and centralized repository of data, and we use it to support business intelligence activities such as reporting, data analysis, and decision making. And data mining is the process of discovering patterns, relationship, and insights from data sets. Then we have also web commerce or also e-commerce, or you can say electronic commerce, that is for buying and selling of goods and services on the internet like Amazon or Coupang, you can say. Moving into the early 2000s, we got XML, Extensible Markup Language, or XQuery standard. They provide a human and machine readable way to structure data. Database administration become more automated and making management more easier. This XML is a kind of markup language that is used to encode documents in format that can be read by both human and machines. So it's a kind of flexible and extensible language, and it allows developers to define their own tags and structures for storing and sharing data. Then we had automated database administration. This refers to the use of software tools and processes. They are used to manage and maintain databases automatically without requiring significant manual intervention. This automated database administration can help to reduce the workload on database administrations, and also they can improve the efficiency and reliability of database operations. By the later 2000s, we were dealing with giant data storage system to handle the explosion of digital information. Bigtable was introduced. It's a compressed, high-performance proprietary data storage system built on Google File System. And then we had Amazon and Yahoo that they had a huge amount of data servers, and also they use very big database management system to manage their data. So DBMS, or database management system, as I said, is a software system that is designed to manage and store large amount of data efficiently and securely. It typically includes tools for creating, modifying, and querying database, as well as managing users and control access to data. It contains information about particular enterprise, collection of interrelated data, a set of programs to access the data, and convenient and efficient environment to use. So where do we see DBMS in action? Everywhere. In banking, it handles transactions. Airlines use DBMS for reservations and schedules. Universities manage registration and grades. Sales track customers and purchases, while online retailers offer order tracking and personalized recommendations. It is also critical in manufacturing for inventory and in HR for employment records. Here are some practical examples. A university database you can consider might let you to add new students, instructors, or courses. We can register a student for courses and we generate class rosters. We assign grades to students and compute GPAs. And also we can generate transcripts. So a university database can do many things like what you use every day. Before DBMS, we had file system to store data. This file system controlled how data was stored and retrieved, but they had big problems. Data redundancy was one of the big problems of file system, and also inconsistency arose from duplicate files. Accessing data was very hard we often had to write new programs for each task. Data was isolated in multiple formats, and integrity problems were common because constraints were buried in codes. Here is a list of drawbacks: data redundancy and inconsistency, difficulty in accessing data, data isolation, integrity problems, automaticity of updates, concurrent access by multiple users, and security problems. These were all the problems that file system involved with, and that's why DBMS came to the scene. Let's go back to our databases. DBMS uses three levels of abstractions: physical level, logical level, and view level. The physical level deals with how data is stored, like disks. For example, physically, we store our data on disks, right? The logical level, on the other side, describes the data and its relationship. For example, an instructor record with fields like ID, name, department name, and salary. This is the logical view of a relation, of a table for a teacher, right? This is how we present a table for a teacher. Then we have view label. In here, we define who can access what. A student cannot access the teacher's salary, or a teacher cannot access to all the scores of a student. So here we control access of different users in a database. So here you can see one example. This is the view level, logical level, physical level. Although all the information are saved in same physical level and logical level, by different user can access only some part of data, not all of them. So databases have instances and a schema. The logical schema is the overall structure of data. Then we have the physical schema. The physical schema is how it's physically stored. And then we have instance. An instance is the actual data at a given moment. A key feature is physical data independence. It means we can change the physical storage without altering the logical structure of our database. Data models are tools to describe data, and also relationship of data, data semantics, and data constraints. So all these tasks are described by data models. We have several types of data models: hierarchical model, network model, relational model, entity relational data model, object-based data model, and semi-structured data model. In the case of hierarchical model, we organize data like a tree. In case of the network model, we use a graph-like structure. In case of the relational model, we use tables. The entity relationship model focuses on entities and connections, while object-based models incorporate programming concepts, and the semi-structured models handle flexible data like XML. So the relational model is the most popular model today. In here, we store all data in tables, and it's very simple but powerful. Each table represents a type of data. In here, we have like columns, rows, and these are attributes or features, and here our data are stored in a table. It's the foundation of modern databases. The data definition language, or DDL, is how we define a database structure. For example, we have this command here. This creates instructor table with fields like ID, name, department name, and salary. And here is the type of the data and length. For example, for salary, if it is in dollar, it means $100. Then this is for the cent, $100.20, for example, right? So in order to work with relational database, we need to learn different languages. Each language contains different syntax and notations. So DDL is one of them. In DDL, we have some specific notation and syntax for definition the database schema and table. We can go for database schema, integrity constraint, and authorization. Here we have different kind of keys that later I will explain in details, and also we have authorization or access control. The next one is DML or data manipulation language. These let us access and manipulate data. There are two types, pure and commercial. In the pure language, like relational algebra, tuple relational calculus, and domain relational calculus, we use this kind of language for theory and optimization. But SQL as a commercial language is practical and widely used in real systems. SQL or structured query language is the most widely used commercial language for database management system. It is not a Turing machine equivalent language. It's often embedded in language like Java or Python for complex tasks, like for big data. And applications may use interfaces like ODBS or JDBS to send SQL queries to the database. Database design shapes how the system is built. So we have logical design and also physical design. Logical design decides the schema, what data to store, and how data organized, a mix of business and computer science choices. For example, one shop owner want to ask you to develop a web application for him. He doesn't know the technical concept. He say to you some general understanding. For example, I have these items I want to buy, I want to calculate my profit, I want to make invoices. These are called as business decision, attributes to be recorded in the database. But we have computer science view. It means relation schema, distribution of the attributes among the various relation schema in a normalized form. Then we have physical design. This physical design focuses on the layout. What is layout? How data is stored on hardware efficiently. Efficiently means we should not save data multiple times. Or in other words, we have to minimize redundancy. Why? Because storage is very expensive. For example, these SSDs are very expensive. That's why we have to care to save data more efficient. For example, I show you this table. Do you see any problem here? We have ID, name, salary of a professor, department name, building, and budget. Everything seems to be okay, but there is one problem. This department name refers to a professor, but building is more referring to a department exclusively, not a professor. That's why we have repetitive data here, right? And budget also. So one way is to separate these tables to two tables. One table as instructor, another table as department. Then using some primary key, we can connect these two tables and retrieve data. What are database design approaches? There are two main design approaches. One is ER model, another one is normalization theory. The entity relationship model maps out entities like students, teachers, departments, and also their relationship, often drawn as diagram. So later I will let you know how to draw ER diagram. These are very important in designing databases. Also, we have normalization theory. This normalization theory uses formal rules in order to ensure the design avoids problems like redundancy. So we have to pass 6 levels of normalization in order to start coding. So before coding, we have to follow these rules in order to have efficient tables. It means reduced redundancy. Then we have object relational data model. In here, these object relational models build on the relational models. They are used to support complex data types like nested tables, and they keep the relational structure as well. This blends object-oriented programming concepts with the power of declarative database access. Then we have XML or Extensible Markup Language. This XML was defined by World Wide Web, and it started as a document markup language but became a standard for data exchange. Its flexible nested tags make it ideal for sharing data across systems, and it forms the basis of many modern formats. The database engine is the heart of DBMS. The storage manager handles low-level data interaction, the query processing executes our commands, and the transaction manager ensures everything stays consistent even during failures. So in here we have a storage manager. It's a program module, and it is used to provide interface between low-level data stored in database and also the application program and the queries that we want to retrieve data. These storage managers are used for two applications: one, interaction with the OS, operating system file manager, and also for efficient storing, retrieving, and updating of data. However, there are some issues involved with storage manager, like storage access, file organization, and indexing and hashing. Later, we will discuss them in more details. Query processing has three steps. The first one is parsing and translation, optimization to find the best execution plan, and also evaluation to run the query. Efficiency matters here. Cost estimation helps choose the fastest way, relying on database statistics. Then transaction management keeps the database reliable. In here, we should care what if the system fails, or what if more than one user is concurrently updating the same data. So transactions come to the scene. Transaction ensures consistency even if the system crashes. And also concurrency control manages multiple user updating data at once, preventing conflicts. So we can define transaction as a collection of operations that performs a single logical function in a database application. We should care about the management component and also concurrency control. So here we can see a database user and administration. Database users are here. They use different kind of application and interface. So they may read or they may write. Then we have application interfaces, application programs, query tools, and administration. They all access to the database. So here we can see the role of database management system. Database management system is this part. Here is our data physically stored. Here are our users with different views. They can access to the database. And here are our interfaces in application program, query tools, and admins. And here is the DBMS, DDL, DML, and all are in this part. So finally, database architecture depends on the system. It can be centralized, client-server, parallel, and distributed. In the case of centralized, it means all the data are stored on one computer. In the case of client-server, most of the systems work based on client-server. It means the data are stored on servers like YouTube server, Facebook servers, Amazon servers, and they have separate rules, and the users, they access their server using their phones, laptop, or computers, or anything. Then we have parallel using multiple processors. Then we have distributed across different locations for scalability. So to wrap up, Databases and database management systems are all about organizing and managing data efficiently. Efficiency matters. They have been evolved from tapes to giant systems over decades and are now essential for everything from banking to online shopping. So thank you for watching this video lecture. In this video lecture, we studied what is data, what is database, what is database management system. Then we look at the history, database management system application, examples. We compare database management system and file system and some level of abstractions and data definition language, data manipulation language. So please study and feel free to ask me if you have any question. Thank you for your attention.